Let's solve for the inverse cosine, or arc cos of negative square root of 3 over 2. To find this value, let's recall what inverse cosine means. The inverse cosine gives us the angle theta in the interval from 0 to pi radians, whose cosine equals our input value. In this case, we're looking for the angle whose cosine is negative square root of 3 over 2. On the unit circle, the x-coordinate of any point represents the cosine of that angle. We're looking for a point where the x-coordinate is negative square root of 3 over 2. This value is approximately negative 0.866. When we draw the angle from the positive x-axis to this point, we can see that this angle is in the second quadrant. This is one of our special angles that we should remember. It's 5 pi over 6 radians, or 150 degrees. Let's verify this is correct. In the second quadrant, we can draw a reference triangle. The hypotenuse is 1 since we're on the unit circle. The reference angle with the x-axis is 30 degrees, or pi over 6 radians. In this 30, 60, 90 triangle, we know that the ratio of the adjacent side to the hypotenuse is cosine of 30 degrees, which equals square root of 3 over 2. Since we're in the second quadrant, we take the negative of this value, giving us negative square root of 3 over 2. Therefore, the inverse cosine of negative square root of 3 over 2 equals 5 pi over 6 radians, or 150 degrees. Remember, inverse cosine always gives us an angle between 0 and pi radians, or 0, and 180 degrees. This is why we got the angle in the second quadrant.